The next topic is lamps. So we have studied how to measure light, how to design a lighting system using a how they will be considering for designing the lighting system, luminance, flux, intensity, everything. So now we have decided. So what amount of lighting we will be providing? So particular area we have to provide. For street lights they will be providing different types of lamps. For home they will be providing different types of lamps. So we need to know the lamps and its ratings and its working principle, where it will be applicable in the day-to-day life. So different types of lamps. Next topic is different types of lamps. So in lamps there are different types: gas discharge type lamp, light emitting diode. Like these types of lamps are available, or energizing lamps are available. So we will be seeing one by one. For gas discharge type, let us assume vapor lamps. We have seen different, we have known mercury vapor lamp, sodium vapor lamp. These vapor lamps we have known. So for gaseous discharge, that is by supplying electrical energy, the gas inside the lamp will get ionized and that will emit light energy. So that type of lamp is called as gas discharge type of lamp. For best example is mercury vapor lamp. In mercury vapor lamp, the lamp tube is coated with a fluorescent materials or any other pass-per materials, and inside the tube there will be a high pressurized or low pressurized mercury will be filled inside the tube. Once this tube gets energized, once this gas gets energized, it will flow from one point of electrode to the other point of electrode, ionizing all the vacuum area, and that will emit light rays that may be of different colors, and that will emit ultraviolet rays also. So these light rays will be converted into visible region, and that will be displayed as a white light with the help of a pass-per coating on the surface of the tube. So let us see the construction of the mercury vapor lamp. The mercury vapor lamp consists of a arc tube. So this is a arc tube. Inside this arc tube, a high pressurized mercury will be filled, and also an argon gas will be filled as a medium for transferring these mercury when ionized, and heat up and warm up the tube. For once the mercury gets ionized, that will be start discharging in a slow manner. So in order to improve it, we have to heat. There should be a little amount of heat. While argon gas is there, that will also create a heat, and that will easily discharge the mercury from one end to the other end, and the mercury will completely get vaporized and it will emit light rays. So inside the tube there will be two gases, high pressurized mercury gas and argon gas will be present. Mercury gas is for emitting light, and argon gas is for vaporizing the mercury for easier discharge. Okay, and these two main electrodes will be placed at the end of the tube. Also an auxiliary electrode is present. We will see the construction and working of the mercury vapor lamp together. Here the two electrodes are there, main electrode and auxiliary electrode are present. When you give a AC supply to the lamp, at first see here main electrode will be conducting, but this electrode is resistant, that is it cannot able to vaporize the mercury due to the high resistance between both the electrodes. In order to vaporize the mercury, we are connecting an auxiliary electrode with small amount of resistance. After that, we are trying to vaporize the mercury by means of a main electrode, but it is not possible because of the high resistance between the two main electrodes. To vaporize this, we are adding additional starting electrode or auxiliary electrode with the help of a small resistance. If we add this, the current flow will be flowing in this. So this is also, there will be current flow in this also, and this starting electrode also. So this, the distance between the starting electrode and main electrode is very less. So this will generate a gaseous discharge or ionization of gas, and here mercury will be start flowing, and argon also warms up the tube, and mercury will be start discharging towards the main electrode. And once the mercury is completely vaporized, ultraviolet radiation is emitted. This ultraviolet radiation and other visible region of light such as green light, blue light will be emitted. In order to convert this ultraviolet light into visible region or white light, we are coating this tube with a fluorescent material. So this light will be emitted in this, and this will be flowing. This ultraviolet light will not be visible to the human eyes. So we are converting will not be visible to human eyes, and also we will prefer white light, visible light for better lighting. So this outer layer is coated with a fluorescent coating. So nitrogen will be filled on the outside of the tube. So this is to enhance the thermal insulation of the material. Once if we are supplying a current, what happens is that until the mercury gets discharges, the tube will consuming a current. So let us assume this is current and this is gaseous discharge. Until the gaseous discharge happening, your current will be increasing. Your gaseous discharge starts here, and when it completely falls down, your current will be increasing continuously. In order to avoid this, we are providing, so it will consume high current, so it will heat up. So because of consumption of high current, your tube will be getting heated. To avoid or to provide a thermal insulation, nitrogen gas is filled inside the outside the surface of the tube. The fluorescent coating emits the visible white light. So why we are preferring mercury vapor lamp? Why can't we go for incandescent lamp? At first, the Edison invented the incandescent lamp, but the light incandescent lamp, or let us say a sodium vapor lamp also. So this incandescent lamp is also good, but for developing in the lighting systems, the incandescent lamp provides lumens which is less when compared to other types of lightings. So we need to replace this incandescent lamp with a good lighting system. So we have moved over to mercury vapor lamps. So mercury vapor lamp is of low cost. It doesn't need a frequent change of, it will not glow for so easily. So we are preferring mercury vapor lamp. So mercury, where will we see the mercury vapor lamps? For high amount of lighting system in street lights. Mainly in street lights we will be seeing a mercury vapor lamps. Your next lamp is a CFL. CFL is nothing but compact fluorescent lamp. See, we have seen fluorescent lamp, that is tube lights everywhere in our home. Why does we are using compact fluorescent lamp without fluorescent lamp? Yeah, fluorescent lamp is we are using everywhere, but in compact fluorescent lamp, why we have the same in replacement of incandescent lamps in our domestic appliances such as in rooms, living rooms, there we are using incandescent lamps. The lighting provided will be of dim lights. So we are replacing that with a compact fluorescent lamp. Fluorescent lamp working principle is as simple, which we have to incorporate in the replacing the incandescent lamp. To avoid that fluorescent lamp working, because it consumes more amount of power while considering the compact CFLs or fluorescent lamps. So we are replacing this with a incandescent lamp with compact fluorescent lamp. The construction feature itself will be different while considering the fluorescent lamps. See, fluorescent lamp will be of a tube. Electrodes will be present. Once it is ionized, it will be the gas in it ionized, it will be emitting light energy. The same principle is applied here in the CFL, but at the base of the lamp, like it is designed to replace the incandescent lamp. So the tube is like a spiral or a single tube, it will be there. So a small compact tube will be there. This is of compact tube spiral lamp structure. At the base of the lamp is a housing for electronic ballast, that is for starting on for controlling the starting and dimming property of the light. So electronic ballast circuit will be present. This is the construction of the compact fluorescent lamp. The working principle will be similar to the mercury vapor lamp, that when you supply a current to the main electrode, your gas in the tube will get discharged and that will emit ultraviolet radiation. So this ultraviolet radiation is converted into visible light with the help of a Passpar coating. So we will see the control circuit, electronic ballast circuit present in the CFL. The electronic ballast circuit consists of a, we will be supplying a AC input. There will be a electromagnetic shielding filter will be there, and rectifier unit, and half bridge circuit, tank circuit, resonance circuit, and tube lamp will be there. From there, there will be a dimming control circuitry also will be there, current sensing unit, and that will be given as a feedback, and this reference will be given to the input for supplying the current. So as I said, for discharging the gas inside the tube, there will be a continuous consumption of current. So this current will be continuously increasing until the gas gets discharged. So once it is getting continuously consuming high current, if it is if it starts discharging, so the current will be gradually increasing, it will be in an increasing manner. Once the current gets completely increased, a tube will be burst out. To avoid that, we are providing a dimming circuit. So we should not, so if our application is good, then there should not be any drawback. So to avoid those drawbacks, we are adding an additional circuit. So we will see the working of this block diagram. See, we are supplying AC input to the AC input through this housing. Here, these unit consist of these blocks. You will be having a EMI filter, that is electromagnetic radiation filter here, to avoid the resonant or a varying voltage in the input side. We are using EMI filter that will filter out the supply voltage and will be given to the rectifier. Here for operating, for energizing the mercury or gas present inside the tube, that we need a high frequency input supply, but we are getting 50 Hz only from our input side. So for converting this low frequency thing into high frequency, we are using a filter and rectifier. So here what happens, your AC will be converted to DC, and here your low frequency signal is converted into high frequency AC and will be supplied to the lamp. In this unit, your low frequency AC is converted to DC, and this DC is converted to high voltage, high power AC, and this tank, from the tank circuit, your high power AC is converted to high power and high frequency AC supply, and that will be given to the lamp electrode. This causes a ionization and a light will be emitted. Once this light emitting is continuing, that is gaseous discharge is continuing completely, until the gas gets discharged, your tube will be continuously consuming current. So we need for increasing current, once the current set limit is increased high, your tube will burst out. So to avoid that, we will sense the amount of current consumed by the light through the current sensing element. This current sensing element, from this the current is given as a feedback, and your reference for dimming the light or for a low consumption of current, you will be giving an input, a set limit. So beyond this current, the light should not be consuming. If it consumes, it will burst out. So that current will be measured. So these two will be continuously measured, and the error will be given to the bridge rectifier. This will reduce the amount of power flowing through the lamp, amount of current flowing through the lamp. So and your light gets dimmed, or your light power consumption is controlled in the control circuit. This is how your compact fluorescent lamp works. The next light is the LED lights, which is the light emitting diode. As we have discussed the diode and light emitting diode working principles, it is now simply I will be giving directly the concept, the principle behind it. There will be two semiconductors, N-type and P-type semiconductors, combined together to form a PN junction. Here in a light emitting diode, the N-type and P-type material, the doping level for N-type is high. That is, N-type is doped heavily and P-type is lightly for the emission of photons. So when you give a positive and negative, when you give an electrical supply, what happens is that your electrons will flow, your charges and holes will get recombined. Because of this recombination of free electrons and holes, your light energy will be emitted. When you supply the holes and majority carriers, holes in P-type and minority carriers in electrons in N-type will be rushing towards the terminals. Because of this, the holes present in the N-type and P-type will get recombined with the electrons present inside them. So this recombination of free electrons and holes emits photons and lights. This is the working principle in LED. So generally we are considering PN junction diode. In that also holes are present and electrons are present. So why does it doesn't emit light? Here there is a concept called direct band gap and indirect band gap in the semiconductor. If the semiconducting material is of direct band gap, it emits photons. If the semiconducting material is of indirect band gap, then it emits heat energy. That is so we have seen in silicon and germanium. Once the current flows inside the semiconducting material, a current will be repeatedly flowing in it, and that results in that will heat up the material, but it doesn't give any amount of light energy inside this. Here also a current will be flowing inside the light emitting diode, but the energy emitted is in terms of light. In generally we would have seen this small LEDs, one with a high cathode and anode terminal, that is highest terminal is anode and lowest leg is called cathode terminal. Inside that, this thing P-type and N-type doping will be available. On that the light energy will be emitted. The plastic dome will be present in the LED. This is for providing insulation, we may say, but it will give different types of light when we have given a color coding. So we have to choose the P-type and N-type material for providing different light, different colors of light. So if we use for us, let us take the P-type and N-type materials of gallium arsenide. If we use gallium arsenide, then LED will be formed. For emitting, if we use P-type and N-type with gallium arsenide, this combination gives light emitting diode. So for providing different lighting, different coloring, we will be adding another impurities, that is aluminum gallium arsenide, aluminum gallium nitride. So this will give red, orange, yellow, like that. Different colors for giving different colors of light. We will be using different combinations of gallium with arsenide or nitride things. So this is how your LED works. So as I have mentioned, direct band gap and indirect band gap, we will see the how it will be present. In direct band gap, your photons will be emitted. In indirect band gap, thermal heat will be emitted, as I said. the direct band gap is the thing in which your valence band and conduction band will be straight away directly present. It will be, if you see the angle, there will be no deviation in it. So it will be, the angle between them will be 0, it will be the conduction band straight away, it will be lying in, the valence band will be straightly lying down on it. But in indirect band gap, your conduction band and valence band will be tilted off. There will be no direct transition of energy. So it will be off in a different angle. So this will emit only heat energy. If it is directly present behind the conduction band, then it will emit photons or light energy. This is the basic concept behind the LED. But in our home, we are using a white LEDs. These are small things we will be using in the computers or any other small microprocessor boards, or for indication purpose in instruments, measuring instruments, we will be using this LED. But we are using white LEDs, that is like that will be looking like a CFL lamp. So the tube on which the diode will be coated, and the tube it is formed again is coated with a fluorescent material for emitting huge amount of light, for different combination. For giving white light, the primary, all the three primary colors are mixed. That is, your combination of p-type and n-type material, you are using aluminum, gallium, arsenide, that will give green color or yellow color. Like that, your three primary colors are mixed in the construction of the LED itself. So that will emit white light. Or coating the, we will be generating a ultraviolet light or blue light, that will be coated with a PASPER layer outside the fluorescent material. Then it will convert this into white light, and the white LEDs will be glowing. So this is how your white LEDs are made. The basic concept behind the light emitting diode is that the principle on which the PN junction diode works, the same principle where in which light energy is emitted. With this, the topic light is over. The next is the sound. The sound is also a form of energy. I am speaking. This is also a energy which is transmitted and will be vanishing off. Your speech, or if you are hearing any songs, that will also be a energy which is transferred in a air medium. That is, if I am speaking, a pressure exerted on the air, that will be considered as a sound. I am giving a signal which experiences a pressure on the air. So that pressure will be traveling from high pressure to low pressure region, and it will be vanishing off until it becomes zero. So the fundamental things in sound is that pleasant sound, that is normally we are saying that as a sound. An unwanted sound, that is called as noise. So how we are considering that as an unwanted sound? If I am speaking, if I am the key speaker here, I am speaking, that sound is called as a sound which is wanted. That is a necessary sound. If there is a additional fan sound is mixing with my sound, which is disturbing the listener, then that fan sound is called as a noise. We are moving in a traffic. If there will be a horn sounds. When you are pressing, when you are giving horn, then it is not noise to you. When some other gives horn, that will be considered as a noise to you. So the noise is dependent on the user or observer who are thinking, who are considering which is wanted signal and which is unwanted signal. So not all the signals all the signals or sound are not noises. The noise, all the sound are not noises, but the noises is declared by the or considered according to the observer. So for in industries, there will be huge machine noise will be there, and if we are in a film or filmographies, the unwanted noises will be there in the recording side, in a sound recording or in a video recording or everywhere. The unwanted signals, unwanted sounds which are disturbing the actual sound is called as noise. So we need to eliminate the noise in order to give a good quality sound. So for eliminating noise, we need to measure it. So we will measure the sound or noise in terms of decibel. Decibel is nothing but amount of pressure exerted on air at one point, that is amount of pressure at this point to this point, pressure from this point to this point. So there will be continuously changing pressure will be exerted on the nearby. So I am speaking here, the voice is reaching. So this is how it starts. It is a sound waves or transverse in nature. It starts here. This sound exerts a pressure on nearby medium. This exerts a pressure on here. This and continuously it will be exerting, and it will get vanish out until the pressure gets reducing. So it will be in a decreasing nature at one point to another point. So I will be calculating noise in terms of decibel as I said, 20 log P1 by P2. So this is how you will measure the sound, any sound. So if it is of noise, you will be measuring the noises in terms of decibel. So for measuring this noise levels, we are using a noise meter to measure the sound. For a lux meter or light measuring meter, there is a working principle that converts light energy into electrical energy. Similarly, in noise meter, that should convert sound energy into electrical energy. So which instrument it will convert sound energy into electrical energy? Generally, we in everywhere we are using microphones. So this converts sound energy into electrical energy. Inside the microphone, what will be there? There will be a here this pressure exerting on the air will be flowing through the microphone. That air duct will be present, that will exert a force which will generate a voltage. Because of the deformation, it will generate the voltage. This is how your microphone converts sound energy into electrical energy. So inside the noise meter, microphone and a filter. So this is given to analog to digital converter and through microcomputer and display device, which will be displayed in terms of decibel. This is how your noise meter measures the noise. Thank you.